Hey, math fans! Welcome to Math Olympiad Academy, your trusted space for advanced problem solving and logical reasoning. We sincerely thank our subscribers and all viewers for your continued support. In Lesson 26, we present a rigorous, step-by-step solution to a fundamental problem in three-dimensional geometry, finding the distance from a point to a plane. We will identify the normal vector of the plane, apply the distance formula derived from vector projection, and interpret the result with geometric precision. In this problem, we are given a point M with coordinates 5, 3, 4, and a plane P defined by the equation 2x minus y minus z equals 7. Let H be the orthogonal projection of M onto P. Our question is, find the value of HM. Our objective is to understand the method for computing the distance from any point to any plane in space. How to use the plane's equation to identify its normal vector, how to apply the standard distance formula with full awareness of its derivation, and why the result is always non-negative, as distance must be. Before we begin, let us start with a concise recall. Consider a plane defined by its equation, ax plus by plus cz plus d equals 0. Its normal vector is defined by the three components, a, b, c. And consider a point M in space, given by its three coordinates, x0, y0, z0. Since our aim is to determine the distance between point M and the plane P, here is the key idea. Distance to a plane means the shortest orthogonal distance between point M and the plane denoted P, not the distance to an arbitrary point on the plane. So, the shortest distance from point M to plane P, denoted HM, is given by the standard expression HM equals the absolute value of the quantity A times x0 plus B times y0 plus C times z0 plus D, all over the quantity square root of A squared plus B squared plus C squared, where H is the orthogonal projection of point M onto plane P. Note also that the absolute value ensures the distance is non-negative. Now, let us begin solving the problem, in which we consider a given point M with coordinates 5, 3, 4, and a plane P defined by the equation 2x minus y minus z equals 7. Knowing that H is the orthogonal projection of M onto P, it is clear that the normal vector of the plane P is defined by the three components 2, -1, -1. So, its magnitude equals the square root of 2 squared plus -1 squared plus -1 squared, which is the square root of 6. By applying the previous expression for HM, this yields HM equals the absolute value of the quantity 2 times 5 plus -1 times 3 plus -1 times 4 minus 7, all over the quantity square root of 2 squared plus -1 squared plus -1 squared. After simplifying, we obtain HM equals the absolute value of 10 minus 3 minus 4 minus 7, all over the quantity square root of 6. This gives HM equals 4 over square root of 6. By rationalizing the denominator and simplifying by 2, the distance HM becomes equal to 2 square root of 6 over 3. Thus, the orthogonal distance from the point M with coordinates 5, 3, 4 to the plane P is 2 square root of 6 over 3. Conclusion: the distance from the point M with coordinates 5, 3, 4 to the plane P is 2 square root of 6 over 3.
I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!